the largest funding rounds, and most of these largest funding rounds will not be like Series A, would be mostly Series C plus. Okay, so in these funding rounds, these are the top 5 companies. Okay, do you see anything there? So the first company is a food delivery company. The second company is a hoteling company. The third is an education company. Fourth is a retail. Fifth, again, something related to food finding. Anything that you see common? So they all are technology companies, right? They might be into different industries, but the bottom are technology companies. The businesses, all that industry is just a sideline for them. Okay, but it's not so. Technology company also has the largest failure rate worldwide. Okay. By the way, if you want to earn money, become a developer, and there's no great place to become a developer than in Chennai. Okay. But if you want to start something in information technology and you're just seeing the funding rounds, there's a bad news also. And 90% of the companies that start fail in their first years of operation. Okay, no matter if there are billion companies, the people are billion, the ideas billion, they still can fail. And only more than 2 to 3% actually survive after 3 years of operation. And this statistics might be slightly higher, at least in absolute terms, if not percentage terms, for information technology, because the entry barrier in information technology is low. But to survive there, it's very tough. Okay. So what could be a good mantra for success in this? This slide is taken from Salesforce.com. They conducted a survey of around 200 companies, 200 startups, and they found out what are the common things that of all the successful startups from them. They see that the timing, the team, ideas, business models, and fundings were the key important things in this percentage. I would slightly differ from this because as a statistician, I recognize that correlation is not causation. Okay, and these type of surveys are very simplistic. They just see what are the common things going on. Okay, but if you want to replicate that model, this is not something that you can peg your chances upon. Okay, so I would like to put it more into a causation, correlation, and a mathematical model. It is a right team. If you can get the right team, that right team can find out today what is the best timing for. You don't have to start your business 10 years, 20 years from now, or you don't have an opportunity to start a business like Five had started a business 5 years ago. So it's not about what business I have to start, but what business I can start today. And that is where which technology has come to a pinnacle such that the timing is right to start and gestate today. And then I have to also get into the life cycle of it. If I have to survive for the next 3 years, 5 years, and maybe in 2 years I need to be at the top of that, what are the technologies that will be implicated into that industry? And once you have got the timing right, then obviously what follows is the business model. So if I've got the industry right, what are the things that are forthcoming in this from a customer perspective, acceptability perspective, and from an ideas perspective? Okay. If you see the middle layer, what the right team does is timing, business model, and ideas. This is in short what I call disruption. In fact, in the first slide that you saw, all those 5 companies, they disrupted their industries. Okay, so something like Oyo or something like Swiggy, what they did was they didn't start a new business. They entered into an existing industry, existing business. They just disrupted it with the technology. Now, if I go to a hotel, the first thing I do is check Oyo, check Make My Trip. I do not go and check like local judge dials or hotel portals for them. Okay, and I make the booking mostly from there. So this is a technology-based disruption. And so essentially what they are is into the industry of disruption. And to be more precise, it is AI-based disruption. It is not just an automation-based disruption. This is a key distinction factor. Most of us believe that they are technology companies, they are good in technologies, they would have like a large team of engineers who are deploying, say, software products over there, and that is what makes them successful. It's not so. Most of the software industries that were pure automation industries now do not exist. Because if you have to disrupt with an idea. And for the implementation of that idea, you require some sort of an AI to move ahead. Okay? So for example, in the case of Swiggy, Oyo, Uber, all these things, let's take a more realistic example like day to day. You shop a lot, right? You go to different e-commerce companies. Sometime back, if you would have seen, there would have been at least 20 e-commerce portals that you would have gone to. Why I take example of e-commerce is because e-commerce has to be completely automated. So every player that comes, no matter how small, how big they are completely automated, right? Otherwise, you cannot run e-commerce. It's just a simple commerce and brick and mortar retail. Still, you find out that most of the companies that erupted some time back have died off. Okay, now you have mostly 2 to 3 major e-commerce players right now, or at least that captures your share of mind. The first thing that you would go to. Why is it so? Why did you shun all the remaining 17, 18 players and why only 2 survived? Was it automation? It was AI, not just the AI that you interact with, but the AI that you do not even see. AI in supply chain, AI in distribution, everywhere. Okay? That is what makes them survivable. So the things that you cannot see, maybe investors can see. They get the funding. They can survive longer. In fact, if being a marketing student, you all know that most of these companies are not running in profits. They are burning cash like anything. Still, they are the biggest name. Okay, that's a different model altogether. But if you see this international trends, most of these companies are the AI funding, despite the fact that their economy is not going good, the AI funding is still rising, right? Except Germany. You see what is the problem over there? There's a documentary that speaks about Germany. Okay, why Germany was so high into earlier industries and why Germany, despite coining the term Industry 4.0, Industry 4.0 terminology itself has come from Germany. But they are not doing so good in artificial intelligence. And people believe, or that is what is also shown in data, that it is because of the success in conventional industries that they didn't adopted AI because they wanted to keep improving those conventional industries. And that is where they have not far behind in AI, whereas all the European countries have done so. So basically now we are talking about AI-based companies. Okay. This is again not my slide, mostly from consulting. And these are the 3 areas that you need to see in any business. So maybe if you are a seed capital, what is most important for you is like value creation. But in case if you go up till Series A funding, you will not be able to do that till you do not realize value. You have to show the value to the investors and the customers before you can move ahead. And if you want to actually survive in the business, then your idea should also be defensible. The key common trait in all of these things is these are all AI driven. Is there manual control that I can take of the system? I think. Okay. Yeah, it's changing the slides automatically. This is okay. Fine, it has come. So the key ingredients in all of these things, although the names could be different, but underlying way today to survive or get an edge in that is actually analytics. For example, if you see quantifiable ROI, buyer's readiness, and all those things, now you do not use simple metrics to do that. Now for each of that, you have like a ready deployable AI system that will go behind and run in your system, and all these things underlying will be automated and intelligence worked into it to do that. And that is how you become a scalable business model. So let's talk about our context. This is a slide which has been taken from a recent report from Niti Aayog. Niti Aayog says that, okay, or the underlying belief that it is that we are slightly lagging behind in AI. India has the best of brains in both mathematics, the business ideas, and maybe other things, but maybe from an execution perspective or the brain drain or whatever you may call it, we are not so ahead in AI as we should have been. In fact, I do not know if it is a perception or reality, but China seems to be much ahead of us. Okay? And that is why the government has brought up a program. They want to push AI into everything. Of course, they cannot make policies for the private sectors, but at least for their own sectors, they have made this 3-point agenda. They want to push technologies into 3 things: sense, comprehend, and act. These 3 types of technology they get is like visual analytics or computer vision. The second is the NLP, and the third is the expert systems. Okay. Let's talk in brief about what are the state of art in these technologies, and then we will talk about the real topic of our presentation, which is AI solutioning. Okay, so computer vision is mostly focused on deep learning for vision, which is convolutional neural networks and architectures. Why I use the word architectures is because CNN itself is just a model. Okay? The way that you use it, that brings about different use cases to life, is different architectures of it. So for example, the 2 very common architectures these days that are empowering a lot of innovation is GANs and attention mechanism. So just a brief synopsis, people who do not know GANs before I go into these models is, GANs is generative adversarial networks. Now how do they work is a simple image detection or object detection model. It will take image as an input, and then it will make some features out of it, a very dense matrix out of it. And on the basis of those matrix, it will tell you what type of objects are there in the image. Or it may tell you in general what that image categorize up to. So for example, let's take a very simple example. I'm trying to categorize dogs to cats, okay? Or in doctor's example, a cancerous lump versus a benign lump, sort of a thing. Okay, I take an image of it, I'm then trying to see whether it's a cancerous lump or a benign lump. So now how this works is, it will, from the image, it will convert it into a dense tensor, and on the basis of those dense tensors, it will have 2 prediction probabilities, a cancer or not a cancer. Okay. Now up till here, we call it classification. Now on top of it, I apply another network. Okay. This network's job is, it will change the image. It will change some features of the image such that now it will start predicting as some other image. Okay, and I will change these features in a very mathematical way, such that I will change only those features which will change the final prediction into the area which will be of the line that I want. Okay, this is called classification poisoning in general. Okay, which looks like a very negative word, and this is sometimes when I will come to cybersecurity, we'll also talk about that. It's used in negative sense also in that way. But another way that you can do it is, you can actually make it combine different output images. So if I remove the classification layer from the end, and just before where the features are being formed, now if I start changing that, okay, that will take me to a area called GANs. And now I will be training these 2 algorithms that I made in tandem. So I'll be doing some micro changes in the first algorithm, let the second algorithm do its work, and on the basis of that, I'll change the second algorithm, let the first algorithm based on that. Okay, so one very common GAN model that is very prevalent these days is pix to pix, which can transform one image into some other form of the same image. So some examples that are here is, the first is a satellite image. Okay, so on a map image to the same satellite image without actually having a satellite image of the same area. So basically, I will collect millions of samples of images. One set of the samples would be your map images. The second set of samples will be your satellite images of the same area. I'll train my algorithms on that, and then I'll just give it only the map images, and it will convert it to satellite image on its own. Okay. The same thing, if I want to picture something into day and night, I do not have a permission to go there at night. I can just create a night scene of that. Okay. Or some sketch person or artist has given me a sketch, I can convert into a real product using that. Okay. Another applications of GANs with slight modifications is called cycle GANs, which will take one object from one location and superimpose into another object, which means that it can interchange between your backgrounds and your foregrounds. So for example, it can have like a scenery where the zebra is there, and in the same background, now on the same zebras, it will make them horses. Sometime back you heard about nude fakes. fake nudes or deep nudes, similar. Okay. Then the second topic in CNNs or computer vision that is very common or very popular, not common but niche, is attention mechanism. So how do I know where you are putting your attention? Okay, that is the context of attention in a colloquial language. The attention in deep learning is slightly different. It tells about where an algorithm has to put attention on to do its work successfully. Suppose I give you an image, okay? Suppose I give you that zebra image that you see over here, and I ask you to give it a title. What title would you give it? Okay, maybe a zebra in a like Greenland. Now suppose come to the down image, okay? The scenery one. I would still give it a title called Beautiful Mountains in a River. Okay? If you see mountains is on the left hand side, river is down. So earlier, if I would have asked you why you actually termed the first image as zebra in a Greenland or something like that, you'll say, okay, zebra is the most prominent thing, the biggest thing in the center. That is why I started my title of the image from zebra. Okay, but the moment I ask you the rationale for the second image, why you mentioned second image as like a mountain in a beautiful river or something like that, mountain is neither in the center, nor I think even the biggest, maybe the biggest is the river, but still the river came second in your title. Why is it so? Okay, that is when you start thinking of your brain as a machine. Okay, what was happening in my brain that I'm not even able to explain, but I still think that's the right thing that I conceived. That is exactly what attention mechanism does for us. It gives this type of thinking power to CNNs. The beauty of this is that you can translate it into a real colloquial sense of attention that we use in our common life. Okay? So there are some algorithms that are powered by that. We'll talk about these later. But just to walk a bit deeper, and this session is going to be completely flexible. So if you're not interested in the technology behind, we can just wrap it up in 20 minutes. If you want, we can continue it till 50, 55 minutes, whatever you want or interested are in. Okay, so there's something called glimpse sensors. What glimpse sensor does is it will have different aspect ratio, different sizes of the image mapping into another tensor mapping, which is not part of your main tensor mappings for your CNNs. And then it uses projections from it to train your main tensor mapping. The problem with this is not something you can apply a gradient descent or any algorithms to train this, because this equation is not differentiable anymore the moment you have it in second dimension. Okay. Then the second technology that we talked about is natural language processing. Dr. also mentioned NLP in the case of medical. NLP in many of our industries have gone way beyond. Watson was an example. Google natural language translation is a very good example. Nowadays, what is used is not called a normal natural language translation, but a machine translation or machine-to-machine translation or neural language translation. Why it is called neural language translation is we have to understand what is the problem in earlier ways of translating it. As a human, if you know two languages, I will speak to you in Hindi, you will convert it into Tamil. Okay? You do not convert it into English and convert English back to Tamil. You understand the difference between the two? So what is happening is Hindi is being processed in your brain and your brain is producing English or Tamil. Whereas in the first approach, what I was doing was I was translating it into a common background from which all the languages can learn. It was not English, it is more like also a mathematical model itself, but you have to bring it to a common mathematical models on which all the translations takes place. What neural language translation does, it does language to language translation directly without bringing extra layers of models where non-linearity is being lost. So it will take one neural model which will be non-linear, and from there it will keep transferring to different neural models without losing the information in between. If we can do that, we can take it a step forward. Now I do not even want you to write something in Tamil for me to translate into Hindi. I can just ask you to speak, which means it can convert your voice to a neural representation of the voice, that neural representation of voice to directly a neural representation of the written Hindi text. I bypass all the layers in between where I was converting your voice into text, your text into one language to another language, with another, mathematical formulation to third language, and the third language into, say, another voice. I can bypass all of these things and directly convert your voice into some other language voice or text. Then we have got a bit more advanced. So Jeopardy was something that started our interest into deep learning based and knowledge representation based system, because that was the first system that actually defeated the counterpart in a very, you can say, like a visible manner. But otherwise, all these technologies were there to do that. How it was able to do that was through knowledge representation, not just NLP. Okay, so in academics, you have different fields. One is information retrieval, and then there is NLP. And you can combine them in different iterations, different ways to bring out different solutions. And in knowledge representation and information retrievals, one of the good area to talk about is semantic knowledge webs. Okay. When I say knowledge graph, that is just a colloquial representation of one of the formulations of semantic knowledge webs. But why there are technical languages is because there are different types of webs and there are different types of semantic representations as well. Okay. In fact, there are different sort of representations of knowledge graphs as well. What we were traditionally using earlier, at least at the time of Jeopardy and other things, was something called an RDF-based knowledge graphs, or a triples-based knowledge graphs, where everything would be converted into a triple. All the fact that you tell me, okay, I'm giving a talk over here, okay, and this place is in Chennai, and this is the hotel residency, okay. So all of the complete sentence I have broken down into very simple sentences, okay, or short facts, and each of these facts I've converted into a triples, which is a subject, object, and a relation. Okay. I am giving a speech over here. I am one of the subjects. This location might be an object, and I'm giving speech as a relation what I'm doing over here. Correct? So you break everything that you see into small facts, and you break each of those facts into subject, object, and the relations. And you store them into a database, which can do one thing. It can take into it billions of these facts, and it can run very fast queries on retrieving these facts. Now, obviously, this cannot be our normal relational database or document database like Mongo's and other things. So these are specialized data sources. But there was a lot of problem in that. As humans, how do we think about facts? It's not just in the form of triples. We associate a lot of context around those triples, okay, or even the facts that we see, okay, which is slightly different from two disintegrated facts. So I am giving a talk over here. This place is in Chennai. If I represented it as two different triples, then I have to go a long-winded route to find out that I'm giving a talk in Chennai. Okay? But if I represent it in a graph, complete graphical manner, I can say I'm giving a talk in Hotel Residency Towers, and Russell Hotel Residency Towers is directly connected to or is in Chennai, which means that I now have a direct path from where I'm giving the talk to that city. So in earlier example, just to validate the fact whether I'm giving a talk in Chennai or if I have any relation from Chennai, it might not be a direct relation. I might have to go a long way, and I might have to actually go deep dive into my traversals. Whereas in the second way, the connections is very real, and this is a second level connection directly, okay, from the hotel to Chennai, which means that it will have a much higher weightage as compared to any tertiary or fourth grade relations as well. So now I can also vary the relationship. This is how our human mind thinks. And this is the new generation of knowledge graphs that is happening. But the literature, at least the academic or the open source literature in this part is weak because most of the systems are coming from bigger companies and they don't want to open source it till they have actually mostly utilized it, or from a commercial perspective. And how companies actually open source or why they open sources? Because they want to increase the community. So initially they will develop a technology, they'll write the main benefits out of it, But to reap any incremental benefits out of it, they have to have a very large followings of it. Okay, so initially Google was using a lot of things internally, okay, and selling them as direct products. Now Google wants to sell its cloud. It cannot sell its cloud to you till you do not know how to operate some of the key AI features in that. Okay, and you realize that these features are better than the competitors, and you get comfortable using that. And to do all these things, now it has to open source it. Same for TensorFlow. Okay, earlier we were doing deep learning not in TensorFlow. TensorFlow was not even there. It was like proprietary to Google. We were doing it mostly in PyTorch. Who owns PyTorch? Facebook. Okay, along with Cafe now. Not directly owns, but a major contributor of it. So what were people doing earlier? For scientific community, there was one language called Theano. Most of us who were doing deep learning some time back were mostly doing in Theano, which is like not even a deep learning system, it's a mathematical representation system. It will make making deep learning models and the gradient descents on it or the optimizations on it simpler for you if you can just define it mathematically. But you cannot operate it without proper knowledge of all the underlying mathematics and statistics of it. Okay. So all these industries have an interest in making things popular, but by the time you wait for them to make them popular and open, you might have already missed the bus if you want to have some other objectives in mind, not to just use it like as a user. Then the third technology that I want to talk about is deep reinforcement learning. Before understanding deep reinforcement learning, we have to understand something about reinforcement learning. Okay? Sometime back, we were taught that in machine learning or in analytics, there were two different ways. One is a supervised machine learning. The second is unsupervised machine learning. Supervised machine learning is that I give you a data, and I give you the labels for that data. Okay. That labels can be a continuous data, that could be a discrete data. So in the earlier example, whether it's a cat or a dog or a cancerous lump or a non-cancerous lump, the labels are whether it's a cancer or not cancer. And the input features could be anything. Input features could be your questions, the answers to your question, okay, whether it looks large, it looks small, it looks like rounded, it looks like what shape it is. These might be a structured feature, or it can be an actual image that I can use in my deep learning. But the final thing is that I have the labels for it. Okay, so that is why we call it supervised learning. Then there is another unsupervised learning where you are doing mostly pattern detection. Okay, now suppose if I have just got the images of these cancerous lumps, I do not even know what I'm trying to detect over there, whether it's a cancer that I'm trying to detect or it's some form of guilty that I'm detect, or I'm just trying to see if these shapes are what they are. So I do not know what I'm supposed to do, but I need to find patterns in these images. Okay, that sort of learning is called unsupervised learning. Okay, something in between is called an active learning. Okay, or semi-supervised learning, where you are given some data. That data is not enough to make any supervised learning models. Okay, so if you would have gone to the cloud-based Watson systems, or the Watson Explorer, Watson Discovery Studio, how these systems are designed, it will take your data in just your billions of files that you might have. It will give you a knowledge representation system. Depending upon your domain now or your use case within what you're trying to do, you just highlight some words. Okay, and you tell them what these words constitutes. These constitutes a relation, these constitute something that you are interested in, and it will start forming relations on the basis of that. Okay, now suppose in academic context, I'm trying to find out what is the empirical study I should be proposing to my students. Okay, and on the basis of that, I will see what are the best empirical studies that has happened in all the foreign universities that I'm competing with for ranking or other things. And I try to find out like what are the common topics in that. Topic modeling is a very unsupervised sort of a technique, so it's very common. A lot of now deep learning models are also there in topics. But topics doesn't tell you entirely about the relationships between those topics. So start manually mapping those relationships for say one or two paragraphs or one or two texts, okay? And then it will keep showing you new relationships, similar relationships that it is discovering in other text. And then you can refine them, saying, okay, this is right, this is wrong. Okay, this is what I was intended, this was not. And you'll see like incrementally, like with 4, 5 ticks or maybe 10, 20, depending on how complex it is, it will automatically start generating new relationships, which are very, very accurate. This is called active learning. This is again between unsupervised and supervised, but not very different. What is very different and what we are not taught or taught seldom is something called reinforcement learning. Reinforcement learning doesn't talk on labels, it works on reward, which is very similar to how we as humans work. If I ask you one question, why did you join Liba? Okay? Different people give different answers. What I'm expecting is the placement is good. But any which ways. So even if you convert that, the placement is good after 2 years. Okay? So why not join like a 1-year MBA? It gives you some good placement in 1 year. Okay? So right there, I actually started getting into the concept called discounted rewards. Okay, which means something that I get now, 1 year versus 2 years. Now my brain actually senses them at different values. And some of you will actually give me an answer that you want to actually learn marketing or finance because you want to actually get into this company. And why you want to get into this company? Because this is your ambition, which makes it very difficult for me to quantify that. But still, there are ways to quantify different things. But in all of these equations, I'm not talking about either labels or plain patterns. I'm talking about what drives you, what motivates you, which is a reward function. Okay? In our body, the body releases adrenaline, which is a chemical, to various responses. Okay? That is the body's mechanism to give you a reward. And depending upon what thing it is, it might give you an instantaneous reward, instantaneous slow surge of adrenaline, or continuous surge of adrenaline, or like very slow but longer surges of adrenaline. That determines how the body gives you reward. Correct? So it is said that sugar is even more harmful than cocaine. Right? Because the adrenaline injecting power of sugar, the refined sugar that we're talking about, not the complex state of sugar that exists in the nature, it secretes adrenaline at a faster rate than cocaine can do, and it can make you more dependent on a sugar. A lot of cause of our obesity today, or the obesity epidemic, is because of the insulin surge that your body is not able to take, and we continuously are dependent upon that. So deep reinforcement learning adds deep learning to reinforcement learning. A lot of reasons why reinforcement learning was not popular these days is because, number one, it was very complicated. Number two, it was very difficult to form reward factors, and it was very difficult to learn those reward functions if the rewards are actually a real-life reward systems. Deep learning gives it so much power, nonlinear power, to learn these reward functions that it can actually work in real life. So most of the things that you hear right now, what is happening in real world of AlphaGo or Google DeepMind's, backgammon, this is because of deep reinforcement learning, not reinforcement learning. Okay? Let's take an example. So in backgammon, we have like 10 million spaces in the cells that you can take. Okay? And if you are seeing like the combination of moves over there, it will come to like 10 to the power, I think, 30 moves, any of the games. If you have any system that you can learn on that, a supervised learning system, you can do it with the supervised learning also, because there's data and there are labels. Labels are whether I won the game or I did not win, even if it is so simple, although it's not so simple, but suppose if it is so simple. Then also we are talking about for a data set which is 10 to the power 20 in width. And statistically, you need a very large variance across, I would say, trillions of rows of data set to analyze even a partially reduced form of this data set, which means that you cannot do any sort of a supervised learning, even if the use case suggests so. So the only way that you can do is greedily find out the areas. And if someone is from computer science background, they will understand that greedy algorithms are not the most optimal algorithms. In fact, even deep learning doesn't claim to be the most optimal, but in most of these cases, it tries to provide like human level intelligence. In fact, nowadays we are entering into a domain which is called general AI. Okay? What is a general AI versus a narrow AI? Some people call it specific AI, some people call it narrow AI. So as a human, I'm walking, I'm giving it talk, maybe I'm doing my PhD, maybe I'm doing into my company, and I'm doing different tasks. And I do not swap persons, or I do not swap brains to do that. Within the same brain, I have the information and the ability to do different things. This is what is called general AI. Whereas if I train different models to do different things, that is called very specific and narrow AI. And most of the times, it's not even different models trained on different data, it's actually different models by themselves, which means the complete architecture of the model might be different. In case of general AI, it can be either the same learning system or can be the same model with different data represented learning systems. This is the power of deep reinforcement learning. So now that we have known about technologies, let's get to the second point, the timing. What is the right timing for us to get into which type of industry, which types of industries are open by the time you will pass out? So the key industries, if you want to start a business, are cybersecurity, AI in general, which means a technology-based AI that you can implement everywhere, Internet of Things, cloud computing. If you are supposed to get a job in this area, big data processing and analytics, which is like a very generic common terminology for any type of analytics and machine learning. AI in general, which means you can implement it for different companies as such in different forms, AI services, AI products, and again, Internet of Things. So now I'll present some AI solutioning, and my intention is to motivate you towards become an AI solution architect. It is because this AI solutioning that you can bring to life all these things that we talked about, either for a startup that you might be opening for your own or for your company. The sustainability of your business is on the defendability. Defendability is because of an innovation that you have done that people are not able to replicate very easily. If you just pick out just algorithms and just stitch it, it is obviously not as defendable. Okay, and if you are just thinking about a dream, a vision that you cannot bring to life, then it's just a business idea. It's not implementable, it's not realizable. Okay, and just to avoid any IP issues, most of the use cases that I will be taking is mostly what I have worked on personally, or where I am the lead inventor at least. But there are many other use cases that you can just Google around. So just to give you a brief synopsis about cybersecurity, because it might not be like one of the areas that you might be into. So cybersecurity has mostly two basic traits. One is an intrusion detection or intrusion prevention, which talks about the network security part of it, where something called pen testing or penetration testing is very famous. The second part is something which has already intruded. How do you identify it? Okay, whether it's a malware or it's a not malware, and will avoid the implications of that attacking your system. There are different types of malware that has gone through generations. Okay, and if you see the present generation, that is blank. There are no new malware coming up. Why there's no new malware coming up? Because now the malware generation is so advanced that it has surpassed malware detection. So there's no new detectable malware coming up. Okay, or very few detectable malware coming up. So this was a survey done by, I think, IMF sometime back last year. And this is at the height of Brexit. Okay, last year we were going through that. This survey had also like a major respondents from Europe. Even at the height of Brexit, the people who were aware of things in financial domain, they didn't fear Brexit as much, either from a financial perspective. The number one threat that they had was cyber attack. Okay, even if you see Trump and China fighting, Korea, North Korea, South Korea fighting, people were not afraid of any geopolitical things. It was a cyber attack. It is because if a cyber attack happened, it will wipe off 50% of the market cap of the entire financial system. Okay, and the lower bound was 9%. I've been working for something called an SIB, which is a systemically important bank. Systemically important banks are very few in the world, and why they're given this designation is because if they fail because of some reason, it is not about them failing, but the entire economy of not only that country, but the entire world being affected. So the audits that happen in these sort of areas, they have very strict audits. Whereas for some of the lower banks, even if there's an attack, a cyber attack, they may actually not reveal it. They may call it some IT issues or some downtimes, and they may actually hide it. So let's talk about malwares. So what are different types of malwares? You might have heard about ransomware and botnets and all those things. These are variants of malwares. These are not types of malware. Okay. Types of malware are mostly classified into generations. So there's a first generation malware and a second generation malware. So the most simple ones, which are called zero generation malware, I've not kept over here. Most of your antivirus are made for those zero generation, and some are for the first generation. What does the zero generation does it? It will take a file, it will store the hash of the file, which is a unique representation of the file. If you have seen like SHA-256, something like that, it is also one type of a hash, but not that type of hash. There's a different hash that you take for malwares. But it will just compare files with your hashes, okay? And it has data from all over the world, where at least those systems are installed, and will just compare. And it is expecting you're not a government entity who is installing like a normal desktop level malware, which means that if a system has attacked you, it would have been actually made for some other system that is already attacked, and we have it some sort of a signature. So it can do signature mapping, at least for your desktop. Then malware developers start becoming more smart. What they said was, you will match the hash. Okay, let's match it. I'll just encrypt my malware. Okay, they start encrypting the malware. So now you cannot open it. You can still take a hash, but that hash could be easily changed by changing just the encryption key. So I'll take one file, and the moment I encrypt it with 10 different encryption keys, it will give me 10 different hashes, despite the fact that the file is same. And inside my main algorithm that I'll keep like a de-encryption keys. So it will be de-encrypted, and then it will attack your system. Okay, so this is called oligomorphic malware. So malware defenders become smart, and most of your systems now, at least to some areas of oligomorphic, are prevented. Then came polymorphic malwares. Okay, so in polymorphic malware, they actually automated this system of encryption description. Okay, so I'm just 5 minutes away, so I'll just take it away. But the bottom line over here is metamorphic malware, which are very rare, at least for the past generation, happen mostly into defense and government machineries. But now it is becoming more common, and we ourselves are now generating systems that can use AI to generate these malware. And our intention to do that is we want to create a new type of system, which is called an adversarial reinforcement learning system, which will work exactly like what you had seen in the GANs, which was generative adversarial networks for images. We want to make similar system for deep reinforcement learning, such that now one agent can actually detect other agents' malware generated and can fight it. That is the only way that we can see we can prevent a zero-day attack from a malware or a metamorphic malware. You might have heard a lot about autonomous cars. I'm not here to talk about the algorithms of the autonomous cars. That uses, most of these uses deep reinforcement learning. Okay, that's another application of deep reinforcement learning. What I'm able to talk about is a survey that was conducted in Germany. Okay, so Germany had the best car manufacturers, and now they are coming up with different autonomous cars also. And that survey was mostly for the consumers of those autonomous cars, and they had different points on the risk. And most of the consumers said that we would actually buy a car that, in a case of a conflict between saving our lives versus a pedestrian's life, should actually save our lives and not pedestrians. Okay, which means